Alright, hello and welcome to the Daily Space for today, Tuesday, January 7th, 2020. I'm your host, Annie Wilson, and I'm here to put science in your brain. So, let's get at it, shall we? As always, feel free to answer questions. I answer questions, you ask them. As always, feel free to ask questions while I'm doing news stories. I will do my best to scroll up at the end and answer them all. If I don't have the answer, somebody in chat generally does. And just remember, it's okay to not know answers to questions. All right, let's get at it, shall we? Okay, first story is this. You are looking at a picture of the summer triangle with teeny tiny constellation. Let me get my pointer out. Of Sagitta? I believe this is the correct image that you're going to want to see. So it is winter here in the northern hemisphere, and anytime I tried to pull this up in Stellarium, it was just either below the horizon or during the day. So yeah, I went ahead and pulled this out instead. So, yesterday's breaking news from AAS, more than compensated for the past weeks of slow news, from turning lead into gold with neutron star mergers to discovering an Earth-like planet to learning about a star that will explode in the lifetime of some of our younger audience members, but not your hosts. Today's news goes on and on and on. While some of us have been eagerly awaiting to see if Betelgeuse will go boom, a team of astronomers from Louisiana State University have been calculating the explosion date of a different system, V Sagittae. This research was presented by Brad Schaefer and done in collaboration with Johan Frank and Manos Chatsopoulos? I am so sorry. I'm gonna go with Chatsopoulos. Stars self-destruct in a variety of ways. Some of them explode as a result of sudden collapse when they run out of nuclear fuels. Some of them explode when they eat too much of a neighboring star and collapse under the weight of excess mass. Oh, stellar cannibalism. And sometimes stars spiral together and burst as they merge, such as was seen in the Kilonova event with two merging neutron stars in 2017. The event this team is predicting for V Sagittae isn't any of these kinds of events. It is instead something that will happen when two stars merge together violently, but without actually going supernova. Schaefer used the phrase merge burst to describe the event. People, maybe some of you, will see a bright new star flare into existence when a white dwarf star merges with a more massive peer. This is a unique system in our stellar catalogs. There is no other white dwarf star observed to be in this kind of a close orbit with a more massive star. This is a rare combination because large stars evolve faster than small stars, and to get a system with a more evolved, smaller star requires something remarkable, such as two stars forming separately but getting gravitationally bound together later in their lives. Over the past 100 years, observers have watched V Sagittae and seen novae associated with the explosion of built-up material that flowed from the massive star onto the white dwarf. Put differently, material is streaming from the giant star onto the white dwarf, and when the pileup gets large enough, it explodes. And we see those explosions as repeating and cataclysmic explosions. Over time, this system has gotten brighter and brighter in a way that can be explained as the two stars spiraling together. By estimating the current separation and the rate the stars are moving together, it is possible to set a go boom date. And that go boom date is 2083, give or take a decade or so. To be more precise, give or take 16 years or so. When this happens, this star will go from just visible in a small telescope to as bright or brighter than Sirius, which is currently the brightest star in the nighttime sky. According to the press release, the end result of the merger will produce a single star with a degenerate white dwarf core, a hydrogen-burning layer, surrounded by a vast gas envelope mostly of hydrogen. So, yeah. We could talk more on this subject, but there's just so much more news to cover. So we're going to just end it here. And in the future, we're going to see if we can get Brad Schaefer to join us as a guest here on Daily Space. That would be cool. All right, next story. On Monday, the TESS mission announced the discovery of a rocky Earth-sized planet in the habitable zone of an M dwarf star. This is TESS's first such discovery, cataloged as Tango Oscar India. That looks like dude. TOI 700 Delta. So Tango Oscar India 700 Delta. This world is one of 3 known in this system. The team ran 20 atmospheric models to try and determine if the world could be habitable. And for some of the models, the answer was, if you find Chicago habitable, you'd probably be fine there. True story. While follow-up observations with Spitzer made it possible to measure the world's size and mass, it wasn't enough to actually measure the atmosphere. And with a distance of 100 light years, it may not even be possible for JWST, James Webb Space Telescope, or just waiting to be a space telescope, to figure out if this world may have life. But this looks like an Earth-massed rocky world in a habitable zone. This is it, folks. We found someplace that is meteorologically going to be unlike anything we've experienced, but geophysically may be as familiar as the world we walk on. And my dogs have opinions on this, strong opinions. Would you like to go for a walk on this world? I'm sure you would. Come here. Come here and I'll pet you. And we'll talk more about TESS. All right. So TESS also announced the discovery of a planet orbiting 2 stars, such as the planet Tatooine in the Star Wars series. And they found that the excellently named Alpha Draconis is made of 2 stars that eclipse one another. Also known as Thuban, this system has long been known to be 2 widely separated, non-interacting stars. It is actually one of the brightest binary systems we know of. Somehow, no one had previously noticed that the stars periodically eclipse one another. The brightness is likely the reason. Most detectors will get saturated looking at the system and will be as effective at measuring its brightness as a thimble would be at measuring the volume of a bucket of water that is poured in all at once. There we go. As a thimble would be at measuring the volume. Oh my. Okay, so imagine a thimble or a shot glass, and then imagine a big bucket of water, and you're dumping all of the water into the shot glass or thimble, and you can't measure all of that volume of water that's being poured in. You're only going to capture a tiny bit of it, and everything else is just going to go sploosh. So, oh wow. Yeah, just, oh wow. We know that for about 6 hours, every 51.4 the system goes into a primary eclipse. What? And here is the crazy factoid this leads to. Thuban was once the pole star, which means that people navigated by the light of 2 suns alternating for the primary role of true north. Oh my goodness. Oh, and here's the picture of the 2 stars that are of doing their thing together. Just, oh my goodness. Just, wow. And I don't know what this is an image of. Maybe the same thing? No. No. Okay, so there's just so much more news to report, but we're going to save most of it for later this week when we expect things to slow down a bit as folks work to recover from AAS, which ends Wednesday. We do want to highlight one more release that we're still not sure about. A team of South Korean astronomers has done a new and careful analysis of the host galaxies of Type 1 supernova and has looked for trends in the relationship between the kinds of stars they have and the brightness of the supernova they produce. It's been long recognized that there is some scatter in the brightness of these exploding systems, and they find a correlation between the luminosity of the supernovae and the stellar populations of their host galaxies. This work, which is the result of 9 years detailed observations and analysis using the Las Campanas Observatory and the 6.5 meter multi-mirror telescope, seems to indicate that as the universe and its stellar populations have aged, the Type 1 alpha supernova has also changed. This result, if true, I lost it. This result, if true, is one of those things that will instantly turn over 2 decades of research. Type 1 alpha supernovae are treated as standard candles that are assumed to have the same average brightness across all of time. If they are actually changing in average brightness, then our most distant measurements of the universe are based on a bad assumption. In their analysis, this team, which is led by Young-Wook Lee, finds that dark energy is no longer needed to explain our universe's expansion. They admit that extraordinary results require extraordinary evidence, and this would need replicated. If it is replicated, the biggest question in astronomy goes away, as it is just an oops, we made a bad assumption that led us down a rabbit hole. That means folks like Adam Rice, who got the Nobel Prize, will have to ask themselves some hard questions, and we need to think through the justifications we have today for the telescopes we're building to explore dark energy in the future. Telescopes like the W-FIRST mission. It means we may be able to get around the problem of the Hubble constant looking different at different times by just eliminating dark energy from our equations. And those equations would actually be way easier to work with, but only if this paper is true. This is just one publication, but it is by one team that is large, worked hard, and studied this for 9 years, and is publishing their paper in the Astrophysical Journal. Dr. Pamela, who wrote this, is concerned that the results aren't going to be treated to open consideration as readily as they would be if they came from a team at Princeton, Stanford, or Yale. They need to be considered, however, and someone needs to replicate this to see if it holds up. For now, this is the story that we're going to be watching because, let's face it, dark energy makes no sense, and this would be one hell of a graceful way to get ourselves back into a more comprehensible story of our universe. That's it. That is all of the news I have for you today. I'm hoping I got all of the slides with all of the right things. I am going to unbirth the lapdog because lapdog, say hi. Just don't bark. Say hi. All right, go. Be free. I'll turn on the dog cam and then we'll look at your questions. I know Dr. Pamela is in chat, so she might be able to answer some of these way more gracefully than I can. But you know, after all of that, we need some dogs. And we definitely need some Cheerios at dogs. So here we go. And make it rain. Alright. So the dog's got some heart-shaped Cheerios. And let me scroll up. Oh my goodness. Because, whoa. Swap out. I like DPI's comment of swap out to Type 1 alpha LED flashlights. Yeah. Broken Symmetry asked, does this affect dark matter concepts as well? I honestly don't understand enough about dark energy and dark matter to know. Dr. Pamela is saying, nope, dark matter is fine. So it's literally just dark energy. Part of me is like, I am all for simplifying equations and everything. Oh, thank you for the bits, Refmet. And make it rain! Yeah, misleading names are misleading. It just, Astro B has a question. One thing I would like an answer to: if aliens were at Alpha Centauri with our present technology, would they be able to detect us here on planet Earth? I don't know. I don't remember how far Alpha Centauri is. Tardy Toes, making it rain! And speak! And make it rain! Puck's like, I am totally just doing the thing. Alright. Yeah, so Pamela says, I don't think we're... Oh, it's it's about 4 light years. I don't know. Dr. Pamela says, I don't think we're transmitting planet to them, so probably not. Let's see, somebody else had a question. So, dark energy is fine. So will the universe have a big bounce? Hanny wants to know. What is a big bounce? Hanny also wants to know, how long will it take to replicate the results of the "there is no dark energy, our candles are wrong" thing. I've heard that the standard candles might be wrong for a while now, so I don't know. But I think that may have just been people knowing about this work, because it did take them 9 years to complete. A big bounce is a big crush followed by a big bang, so collapse and expansion, and Dr. Pamela says probably not. And Dr. Pamela says, no idea how long it's going to take to get this replicated. I don't know if it can be replicated without another several years of observations being needed. We're probably going to need another several years of observations. If not I imagine at some point you could go back into historical data. So, Puck say no aliens. Refs Matt had asked, why are there so many novae stars in Sagitta and Delphinius? I don't know. I don't know. Hannies wants to know if any of these are going to produce heavy metals. Probably the supermerger. So, plane of the Milky Way passes through there, just lots of stars, and Dr. Pamela doesn't know the chemistry of the merger, and neither do I. So, Raj wants to know, did anybody see Elon Musk dance at Tesla's Shanghai facility? No. No, oh my goodness. Sagitta is a very active part of our galaxy, pipes in Astro B. So I'm gonna look up and see if I found anything else. Merge burst go boom date has much words fun. Yes. Oh my goodness, yes. Yes. I don't know, Pamela, did you have pineapple with your breakfast? Shh. You're either going to, have comments or... hold on. Okay, sorry. I can't scroll and mute at the same time. Mango juice, though. Ooh, nice. Will the moon shadow shield JWST or only in the sky the dark side of the sunscreen is unavailable? I really am not too sure. I think the sunscreen... I don't know. Will the moon's shadow shield JWST sometimes, or only the sky on the dark side of the sunscreen is available? I don't know how just waiting to be a space telescope is supposed to work. I just know it's not going to be in orbit close to the sun. Or not close to the sun, close to the Earth. All I can think about right now is that silly ride from Disney. Russ Matt pops in with, no, the moon will not shade JWST. Mango juice, though, instead. Ooh, that sounds good. Not gonna lie, that sounds good. JWST will be able to see all the sky, but not all the time. Like all scopes, there are season accessibility issues. That whole, you know, pesky world turning thing, even though JWST is going to be above that. And I'm throwing Cheerios at dogs that aren't even there. All right, any other questions? I don't know how to exit this. There we go. Must keep its back to the sun. I mean, that's why it has a gazillion of those sun shields, right? Right? I think so. Whew. Okay. Throw the Cheerios and they will come. They totally do come when I throw Cheerios. I'm still a little freaked out by the heart shapes. Do you think a telescope array should be built and launched to one of the Lagrange points? I don't think... I don't know what it would take to keep... I know there are satellites in arrays, but Lagrange points aren't close. And it is going to be at a Lagrange point. And all I can think about is the expense that it took to build this one telescope. And it's not even launched yet. And I'm really hoping that it's going to end up being like Hubble, where everybody was anti-Hubble until Hubble actually was up there and then stayed working for way past its time. And yeah, but there's no ground to just keep everything stable, and you have gyroscopes, and that just seems like... Yeah, that just seems like a hot mess, as Starstrider says. It's like, we have telescope arrays on the ground. And the fact that they're on the ground takes a whole lot of math out of it, because you at least know where they are. They aren't just moving out there in 3 dimensions. So, LUVOIR, which I feel like I should know what that is, but I don't remember. LUVOIR is going to a Lagrange point. A collection of telescopes connected together. We already layered data. We already layered data from telescopes. So there's that large UV optical infrared telescope. Wow, it's just covering a whole bunch of the electromagnetic spectrum there, isn't it? It's a larger version of JWST. How close is that thing to launching? I'm not bitter. I'm not bitter at all. Have a heart-shaped Cheerio, Tinker. Don't eat my fingers with it. Have a heart-shaped Cheerio, Puck. Have a regular shaped Cheerio, Puck. They're not all heart shapes. They're like mixed. Tinker. Okay, fine. Puck gets it. Any other questions? super soft X-ray sources. The fact that large ultraviolet optical infrared surveyor, that's still a big chunk of the electromagnetic spectrum, because that's optical is what we can see, and then you have ultraviolet and infrared, which is just on either side of what we can see. Ooh. Yeah, that would be cool. Just avoid gravity. It's just a truck, which they're not supposed to be going up this road, but let's pretend that didn't happen. What are my thoughts on the Lunar Gateway? Trying to find a way to word this diplomatically. I don't think it's going to be on budget and on time. I think that's... Hey, yes, I know. You're very delayed. I don't think it's going to be on budget and on time. I think it'll be cool. I think it'll be helpful. It is a space station, but I don't think it's going to be on budget or on time. We're still building the ISS. We're still building the ISS. Just think about that for a second. Like, there's still components, there's still sections to the ISS that we're putting up there. I think for long term, I know Larry's saying it's going to be unnecessary for long. I don't really know too much about it, because I've just accepted the fact that these things are dead to me until they actually happen. And as far as long-term being there, I think it'll be helpful, because I think the ISS is too far away. I think they're talking about having this in addition to a moon base. Like, this would just be kind of the stopping point before you go down to the surface for a moon base or whatever. And moon bases are hard to build. Space stations are hard to build. The regolith on the moon is not like the regolith or soil here on Earth. And yeah. So Guido asks, has there ever been a space mission or project that has been on time? I don't know. Raj Lutheris says, since I learned of NASA as a child, I always wanted to know why there is no ISA, International Aeronautical and Space Administration. I'm getting there. Have some patience, Puck. There are international treaties and there have been international projects, but I think there's a lot of politics, and Starstriders popping in with that there's a UN branch with an unmemorable acronym, so that's probably the closest, but I don't think they collect money and put that money towards projects. I think the closest thing to International Aeronautical and Space Administration is actually ESA. Hey, thanks for following. We'll throw more bits of dogs and make it rain! I think really a lot of it boils down to politics and things of that nature. So I don't know a whole lot about this. I really don't. I know there's international treaties. I know that there's been some international projects, but teamwork is hard, and space is hard. And I think sometimes when you add the two together, when you have different countries with different goals and different ways of just doing things, and literally culture clashes, literally culture clashes, communication differences, things of that nature. You're it adds a level of complexity. So DPI asks, do you know that CSA, Canadian Space Agency, is a contributing member of ESA, which is the European Space Agency? I did not, and I find that deeply pleasing, and I'm not sure why. A lot of places are just like, we want to prove that we can do this ourselves. You know, we want to make sure we have our own access to space, or we can't work with, for a variety of reasons, you know, some countries can't work with other countries. Like, Iran can't work with a whole lot of other places. China and the US don't work together. Yeah. And it seems like with the number of countries that actually do have rocket, you know, programs versus the number of countries that exist, there's got to be a lot of infrastructure. So, a lot of good infrastructure, not just a lot of infrastructure. So yeah, it is frustrating. It is frustrating. Anyways, let's throw some more Cheerios at the dogs. Any other questions? Space wheel would be good. I know everybody's been talking about a space wheel. Spin it up, get some gravity. Spin it up, get some gravity. Oh, I don't think the coffee's kicked in all the way yet. There's just a lot of challenges to living on the moon. There's a lot of challenges. The gravity is not like Earth. I mean, it's better than microgravity. There's still some gravity. But yeah, that was a great launch. Of the Cheerios, yeah. Did you know that the first liquid poured on the moon was communion wine? I thought that was a nice one. One of the astronauts, the name escapes me right now, actually timed his communion to match with the time that it would have happened at his home church. So he was having communion while his fellow church members back on Earth were having communion. So yeah, I thought that was a neat thing. No, he did it inside one of the space things. So let's start our own International Space Agency. Pay employees with Cheerios. I don't know. I can't use Cheerios to pay the bills. Was it Buzz? I can't remember if it was Buzz or somebody else. This was something I found while I was researching space food. Along with the fact that somebody smuggled a sandwich onto one of the space flights. Early astronaut days were amazing. Amazing. The amount of stuff they tried to get away with because there were just no rules. Like the couple that got married shortly before launch, when it was too late to swap people out. They got married and then they told their supervisors, and they had to go on they still had to pull the mission because it was too late to swap people out. And after that, NASA was like, we've got to make a rule that there's no married couples in space. So that's actually a rule because it actually happened. So, alright. I'm not seeing any other questions. Hey, that's enough. My dogs are getting restless. I have work to do. Things of that nature. So this is the last call for questions while I get everything else pulled up and ready to go to roll the credits and things of that nature. I know the podcast has already been recorded by Susie. Excuse me. And once she's done editing it, I imagine it will be published. Hersh Luther says, I wish I could start my own aerospace company and space agency. It's a lot of money. It's a lot of money. And yeah. Barry says, I did not know port wine is communion. I love port wine. Oh my goodness. Rigel16 says, I do and don't want to know how a sandwich was smuggled on board. Sounds kind of gross. I will do more reading on it. And I will have that as a random factoid for another day. So, until tomorrow, yeah, this has been a production of PSI, that's Planetary Science Institute, working in collaboration with Youngstown State University here in Youngstown. Oh, look, it's sunny outside. Ohio. We are here because of you, so thank you. Thank you for all of your support. Follows are free. I do know if we hit $10,000 by the end of the month, which I don't even know if this thing updates anymore, that Susie will go to the salon and get her hair entirely dyed purple. Yeah, entirely dyed purple. So her hair will be bright purple if we get to $10,000. Oh, it does update. Good. I'm still a little paranoid about things not updating. But yeah. Things and stuff. Thank you all for your patience and your support and just everything, because I know this has been a crazy week, but teamwork is what makes the dream work. And Pamela can go and enjoy AAS and have, you know, awesome, delicious food, and we can just run the ship. 'Cause yay. I think that's all the things. I am tired. I'm gonna go, and I'm going to have more caffeine. And I will see you all tomorrow, where we will talk about 2019 in space and spacecraft and things. So until then, have a wonderful... Oh, the next AAS podcast. That's right. That's what else I'm doing today. Let's say in an hour, I'll be live again with the press conference. I saw that the other day, DPI. Let's say I'll be live in about another hour for the press conference. And yeah. When is the next AAS? The dog looks interested. Fine, have some Cheerios. The next press conference is at 3:15 Eastern time. I'll probably be online in about an hour. We'll play marbles or something. And yeah. But for now, I'm going to go get some more coffee. So keep being awesome wherever you are in the world. Have an wonderful insert time of day here. And I'll see you in a little bit. Bye.